Okay, everyone, we're going to talk about DHCP and the need, how that's a critical piece of infrastructure for our LAN, local area networks. And so we're going to start off by defining the need for DHCP. And remember, our DHCP will provide us with a network address. And again, this is for IPv4. We're going to start off with that, and then I'll talk about the need for DHCP for IPv6. But traditionally, right now, everyone is working with IP version 4, 32-bit addresses. Later on, I'll talk about IPv6, which is our 128-bit address. So DHCP provides us with a network address, a network mask, and a network gateway address. So our gateway, which is an address that will allow us to actually leave our network. So as you can see here, I have a PC connected to a switch, connected to a router. Later on, I'll actually configure DHCP on that particular devices. So again, the need for DHCP is to provide us with these required items: network mask, and the gateway. There are other optional pieces of information like a DNS name and a domain name. So I'm going to show you guys how to configure that DHC component on our router. Now, the need for DHCP. Basically, when your machines boot up, we send out a broadcast on the network, on our local area network, and that broadcast is a request by this client for a DHCP address. So we turn on our machines, it boots up, and number one, I send out a DHCP request. In this particular case, our DHCP server, which is our router, will respond with a DHCP offer. I will accept that offer, and so now I will send, by step number 3, will be a request. And step number 4, back from the DHCP, will be an acknowledgement. So that's the process we follow whenever we boot up. So we turn on our machines, and we will get leased an IP address for a period of time, okay? And again, we talked earlier, this process for every machine in this room, this process is followed when we boot up. Now, we say that the DHCP server allows us to scale our network. What do I mean by that? I don't have to manually type in this IP address for every machine. In fact, I have a couple of options. I can either manually, dynamically assign this address, or I can use the automatic assigning. So, and what we want is to use dynamic. This is the preferred way. I don't want to manually have to type those in. Automatic, I want to assign it from a pool, but in dynamic, I'm assigning it from a lease pool. So this is what we're going to learn how to configure our DHCP. Now, so that's the process. I'm now going to log in to Packet Tracer. I have a 2901 router. I'm going to get into config mode. Now, the overall process is first, I'm going to assume that the network I'm going to assign the addresses from, traditional class C, 192.168.10.0 network /24. I'm going to exclude 10 addresses from that network. Why do I do that? Well, I want to exclude static addresses. Say, for example, this gateway address, I'm going to assign that 192.168.10.1. That's one address I want to take out of my pool. So I'm going to exclude addresses 192.168.10.1 through 192.168.10.9. So that's a requirement. Printers, servers, gateway addresses. I want to statically assign those addresses. So I'm going to exclude. After that, I'm going to create my DHCP. So I'll use the network address. And in the network address, I'll just give it a pool, the name. So I would type IP DHCP pool, and I would give this a name such as pool 1. So that will be my address name. Now remember I said I have 3 pieces of information in IPv4. I want to assign the pool name, I want to assign the gateway. So I'll use the command for the gateway. I'll just type default router and give that gateway address 192.168.10.1. That's going to be my gateway address. So I will assign the network address, the pool, and the default gateway. Those are the 3 pieces of information that when you boot up and request that IP address, this DHCP server will provide you with that information. And I'm going to quickly, and then we can verify it, I'll type the show run command, and in that show run command, it'll show you what I've configured. So I'm going to pull up here, I'm going to click on this 2901 router and get into config mode. And so I will type, I'll double click on our router here, go to command line. I will not use the wizard to configure, and I'll press return. I'll type enable, I'll type config T, and now I will start my config. Now the first thing I really want to do is type an IP DHCP. I want to exclude these addresses. So I said 192.168.10.1, and the range is 192.168.10.9. So I've typed IP DHCP exclude address 192.168.10.1 through 192.168.10.9. I'll press enter, and then I will type my IP DHCP pool command, and I'll give it a name such as server 1, press enter. Now you can see I'm in DHCP config mode. Now I'll just type the default command for my gateway router. I'll type default router 192.168.10.1, and then I will type the actual network. So network 192.168.10.0, with my mask, 255, 255, divide 255, got 0. So at this point, I've configured those 3 pieces of information, my network command, my gateway router, and the name of my server. I'm going to type exit. And I'm going to type a do shall run just to look at my DHCP server and how it's configured. So IP DHCP pool server, network command, default router, and so that's how I will configure the DHCP server on my router. I have to remember to go to my PC. I'll double click on that. In Packet Tracer here, I'll just go to desktop, IP config, and I'll change from static to DHCP, and that will allow, you can see, well, right now I don't have the server config, the router config. I'm getting a 169.25.44, which is a default address when you don't have your network configured. I'd like to move on though. We've talked about IP DHCP, or our DHCP server, and configuring it for IPv6. Now, I want to configure my server for IPv6. So, the concept is the same. We need to generate, instead of a 32-bit number, we're going to generate our 128-bit prefix. So, again, we can do for IPv6, it can be manual generation, automatic, or dynamic. And dynamic can either be stateless, and we'll call that SLAC, S-L-A-C-C, or it can be stateful. Now, what's really cool about DHCP IPv6 is that the router doesn't generate the address. All the router does is says, this is the network you're on. The PC generates his own address. The way he does that, he takes the 64-bit network address that the router gave him, and she said, this is the network you're on, and then he uses EUI64 to generate the other 64 bits. Remember I said IPv6 is 128 bits. So in stateless, my IPv6 router will say, here's your prefix. The prefix is 64 bits. But that's not enough for my DHCP address. I also need another 64 bits. 64 plus 64 is 128. Well, guess what we use? We use the 48-bit MAC address of that PC. And then after that, we just add 16 more bits of filler. The two of those together, that's EUI-64, and that allows us to generate a stateless. Now, we have another option here. Instead of using a router or with the switch, here's my switch, here's my router. So the router can say, you know what? Use a DHCP server for IPv6. So we can do that. Right now, in stateless, I send a router, a RA, we call it a router advertisement. The router just says, this RA, hey, here's your network, your FF02, FF02::2, that's going to be my router solicitation. So I solicit the router for an address, or RS, he replies back with an RA, I get my network number, and then I can attach my link local address to that. However, the final piece here is if I'm doing stateful, then I will solicit